We've been very busy preparing, packing, and posting our science boxes. Now, some of you might be joining us without the chemistry kit, but that's fine, no problem. You can still join us. You can listen, watch what we're doing, and ask us questions. Now, apart from myself and Nadia, we're not the only ones here, although you can't see who else is in this building, in this lab, but we do have two other very important team members who are going to be working very hard behind the scenes. Shall we reveal them? Yes, right, here they are. There's Casper, he's our cameraman, and here's Michelle. Thanks, Michelle. Michelle will be looking after the technological part of this party, and you'll be bombarding her with questions, which she'll pass on to us. Now, Nadia, can we have a little bit of housekeeping, because that's going to be important as part of our Zoom party?
Yes, absolutely. So today, for your safety and security, we'll be running this event webinar style. So you can see and hear us, but we can't see or hear you, and neither can anybody else. At the bottom of your screen, you should see your Zoom controls for webinars. If you have a question about the activity we're doing, then type your question into the Q&A box, and we'll answer as many as we can at the end of each activity. Because there are so many of us today, we won't use the raise your hand function. Before we forget, we'd like to say a big thank you to Michelle and Casper, also Hayley, Jean, Carl and Laurel for helping us to get ready, and most importantly to the WA National Science Week Committee for coordinating, and to Inspiring Australia for the funding of this event.
Thanks, Nadia. All right. Before we start, I would like to read the Acknowledgement of Country. I respectfully acknowledge the past and present traditional custodians of this land on which we are meeting, the Noongar elders and people. Now today we actually have families who are joining us from the lands of the Whadjuk and Amangu people. And we pay our respects to the eldest, past, present and emerging. All right, you know what? I want to get started. Yes. So Nadia, I think I want to open the box.
We're going to put our lab coats on.
Oh, okay, we're going to put our lab coats on. So just give us a second. But while we're putting our lab coats on, I want to show you where we are, the building we are at the moment. So here we go. Casper's going to show you. Here we go. This is called a super lab. And this lab can accommodate up to 96 students at a time. We have fantastic facilities here. We have the latest technology, and we are very lucky to be working in such a beautiful laboratory. So hopefully one day we will see you here. All right, I'm ready. I've got my lab coat on.
Yes.
Can we start, Nadia?
Yes.
Let's do it.
Okay, so please open your box, because of course you won't have opened it yet, right?
Well, if it was me, I think I would have. All right, let's do it.
Okay. So, let me open. Yeah, there we go. Yep, I'm going to open mine right out there. Okay.
Okay, I'm going to listen to you, Nadia, for instructions.
Yep.
What to do.
So, first on top should be your instructions sheet. I'd like to draw your attention to the text in black down near the bottom, what you need to supply. There are a couple of items that we can't post to you. So if you haven't assembled them already, please have a quick read of the list, adult helpers, and just assemble those couple of items while we get the rest ready. Okay, next thing is your disposable apron. We know you don't have lab coats, but You can use the disposable aprons in a little red and white bag.
Okay. Nadia, can you show us how to put it on?
Yes, I'm going to undo the apron. There we go. And then it may look a bit funny. That's because you need to undo it gently one more time. It's folded in half. Just be careful that you don't rip it down near the bottom. And then the loop at the top goes over your head. And then you can spread it out over your front and your lap. And you can tie it at the back, like an apron in the kitchen.
Now, Nadia, we're not going to use these ones because we are in an actual laboratory. So we have to use the lab coats that we have on. But for you guys, because you're at home, you'll be wearing this lab coat. Okay, lab coat on. What's next?
Next are our name tags. So you should have 2 name tags in your kit. The most important one is scientist. And
so that'll be me, right?
That's right, that's right.
Okay.
So these are for our kids. You can write your first name on the doctor line and then you can stick it on. So Magda's going to do that. She's going to have Dr. Magda, the scientist, on her name tag. And you can stick that on your apron, or if it doesn't stick to your apron, you can stick it to your clothes.
All right. I know who I am.
You're Dr. Magda. So there's another name tag in the kit, and this one says lab technician. This is for our adult helpers. I work as a lab technician at ECU, so you and I are going to have some little chats with each other today about doing some of the more grown-up parts of the experiments and to help support our scientists. So we can put our lab technician stickers on as well. Okay, next we have our bench roll. Lab technicians will like this because this is to keep your table nice and clean.
Well, also, Nadia, this is going to be our working area. So all the experimental work you're doing today, we'd like you to maintain in this area. That way you're keeping your desk clean.
Yep, so put it down on your desk, shiny side down, which will have the paper side up.
Oops.
And then if anything gets spilt, the paper will absorb it and the shiny side will stop it going through to the table underneath.
Talking about spillages, Magda, we've also given you some paper towels, so put those on the side because you might need to use those as well, so have them handy. All right, what's next?
Okay, next are our personal protective equipment. So you have a brand new pair of safety glasses. They are child size.
I'm going to use the adult size if that's okay.
Me too.
All right, so place your safety glasses. If you have your own glasses, you can put those on over the top like I have and Nadia. Okay.
And next are our gloves. Again, these are child size. You have nitrile gloves, which are blue. They might be a darker blue than this, that's fine.
Now this might be a little bit difficult to put on. So what's the little trick, Nadia, that you always tell me? Show me.
Your hands should be dry. So if your hands are a bit wet, take one of the paper towels and gently pat your hands dry first. That will help a lot.
Okay. Yes, I was feeling a little bit nervous about today, so it's a good idea that we... All right, got my gloves on, got my glasses on, got my lab coat on.
Okay, so we've got our science area prepared, so let's start experimenting.
Okay.
So first, you need to ask your scientists, you need to ask your lab technicians, your adult helpers, to boil a kettle full of water. So I have our kettle here. There we go. It's already filled, so I'm going to put it on and get it boiling, but that will take a couple of minutes.
All right, so while that water is boiling, so you need the whole kettle, fill up with water. The lab technician should do that for you. And while we're waiting, we're going to do our very first experiment. I think I want to do the water beads. So now, oh, sorry, that's correct, Nadia. We want to unroll our periodic table. So please find a rolled up periodic table, and what you may need to do is just roll it the other way. There we go. And that should straighten it nicely. Okay, so let's put that on in front. The other piece of paper that you've got, we won't be using that for now, so just put that as aside. Now, Nadia, the other bit of instruction you gave the lab technicians or the helpers was to prepare water beads. So I'm hoping that they've done it. Do you remember what the instructions were, Nadia?
Yes, they were.
What did they have to do?
So this morning we asked you to tip all of the water beads from the little vial, which Magda just showed you, into a jug, a measuring jug, and then add about a cup of cold tap water and leave them to soak.
Now, if you haven't done that, oh well, that's all right, no problem. You can do it later. So maybe all you need to do now is just watch what we do. Now, we did that because we did listen to the instructions. Can I get some extra water? Yeah.
Sure.
So what you should have now I'll place this in a transparent beaker so you can see quite well. There we go. I've got a nice close-up. So as you can see, the beads are, thanks Nadia, and you probably still have water there. So this is what you might be seeing. Actually, you might be seeing nothing, which is quite interesting. I'll talk about that in a minute. What we need to do is now remove the water and have the beads by themselves. So if you have a sieve and inside your box, you should find, oh, can't find it. Oh, there it is. Plastic round container. So please extract that from your box, have that ready. And I'm going to just pour off the water nice and slowly, and the beads will remain in the sieve. There we go. And now transfer the beads into your round plastic container, and this is what we're going to do next. Take the periodic table. I'm going to ask Casper to zoom in on this if he can. Take the periodic table, place the container with the beads on top of the periodic table, and look down, straight down. You see the beads, but you can't really see underneath the beads. But we're going to do a little trick now. That water you had left over, watch this. Here we go. This will be the fun part, so don't look away. I'm going to start pouring the water, and I want you to observe what happens. Keep looking from the top, keep looking from the top, keep looking from the top. Oh! Are you seeing what I'm seeing? Hopefully.
Wow.
You can now see what was underneath. You can see the elemental
Looks
names.
really clear now.
Yeah, it's very clear. Now, let me just move this closer to me there. So, what have we done? Nothing really magical here. Basically, the water beads are a special type of polymer. Now, if you haven't heard of the word polymer, it is probably a new word, and depending on where you are in your schooling, a polymer is just a long chain of carbon atoms. And you can change the properties of the polymer by changing what's hanging off those carbon atoms. Now, this particular type of a polymer, the water beads, is super absorbent, and it absorbs the water. And you would have recognized that because when you left your tiny, originally the beads were very, very small, and you left them in the water for a couple of days, and then they expanded. So the water beads are excellent for absorbing water. And we're going to do another experiment later on. So please remember this, because we're going to examine another polymer that has very similar properties. Now, okay, so it absorbs water, but why is it that when I had the beads on their own, you couldn't see through and you couldn't see what was underneath the plastic container? Whereas when I poured the water on the top, you actually could see. Well, that's because of something called refractive index. You see, the water beads have the same refractive index as water. Now, that's a complicated word, Nadia, refractive index. It has, that's actually a bit more physics than chemistry, but it has to do with the way light travels through the water, through the bead and the water itself, and it gets bent. Anyway, to put it simply, it allows you to see through because the light goes through the water and it goes through the beads at the same angle, and therefore it becomes visible. I think that's a good explanation. I like that. Now, we've done the water beads. We can put this aside. And I think I want you, Nadia, now to talk about the preparation of the cabbage experiment, which we're not going to do till right at the end, but we need to prepare it now. Okay, so over to Nadia to explain what you need to do to prepare for the cabbage experiment.
Yes, okay. Thank you, Dr. Magda.
No worries.
So our kettle has boiled and we're hoping that yours has too by now. So one of the other things that your instructions asked you to do earlier today was to get some red cabbage, which you can just get from a supermarket, and to finally chop or slice it using a cutting board and a knife. Mine was very big, so I didn't need to cut very much of it. I've only cut, this is about 1/8 of a whole cabbage. You might have needed to use a little bit more depending on how big your cabbage was. And I didn't have a mixing bowl like I asked you to use, so I've used an ice cream tub, but any container that can hold hot water is fine. So I've put about 1/8 of a chopped cabbage in there, enough to pretty much half fill your bowl. A little bit less is okay. And now we have our freshly boiled hot water, which I'm just going to reach over and grab. Safety note, lab technicians, adult helpers, please do this part yourselves. And we're going to pour the hot water over the
Nadia,
cabbage.
while you're doing that, sorry to interrupt you, but we just had a question, really interesting one. And it says, can we use green cabbage? Good question.
It won't work the same, so no, you should use red cabbage.
Okay, thanks. All right.
Now, I've left a little bit of water behind because we need some hot water for our next experiment, but I've put enough water in to cover the cabbage. I might actually put a little bit more in this to just about cover the cabbage. It's not an exact amount, but you need most of the cabbage to be underwater. Remember, this is hot. So lab technicians, please look after this. We're going to need to put it to one side to let it cool down, and we're going to do some other things while we wait for it to cool.
Okay, thanks, Nadia. I'm gonna have that kettle. Thank you. So with the leftover hot water, we're going to do another experiment. Now, guys, what you need to do, my fellow scientists, I need you to now find, or if you haven't prepared earlier, a ceramic mug or a glass, a glass container which can actually withstand hot water, very hot water. So if you could grab that now, or please ask your lab technician to do that for you so you can stay at your bench. And while your lab technician is doing that, and my lab technician has already given me, oh, don't also forget, we need a fork or a spoon. So grab that as well. Now, inside your box, I need you to locate this particular compound. Casper's going to zoom in. It's called Polymorph. Make sure you've got the right compound. So that's what we're looking for. So please locate that. Here we go. All right, so this is what we need. You need your glass. Now I'm going to use a beaker because I'm in a lab, so we don't have mugs here. So we're going to use a glass beaker. All right, hopefully you're ready. So what we're going to do next is open up this container and we're going to pour the contents, the whole contents of this container into your mug or your glass. So let's do that. Now I want you to have a look at this compound and think about what it reminds you of. What do you think, Nadia? What does it look like?
They look a bit like little white beads.
Yeah. Nothing really exciting.
No.
Let's see if they have a smell. No, I can't smell anything. No smell. So they're just white little beads. Nothing too exciting about them. But let's see what happens when we add hot water. So this water has boiled, but we've been chatting a little bit. So hopefully now the temperature is less than 100 degrees. And again, please ask your lab technician, your lab assistant, or your helper to do this for you because the water will be still very, very hot. I want you to now pour the hot water into your mug and I want you to observe what happens. Okay, so let's do it. I'm going to cover, yep, Casper's going to zoom in so you can see. I'm going to try and cover all of the beads. Here we go. That should be enough. Oh, I'm going to put that away. Yep. Thanks, Nadia. And I want you to grab your fork and just move it gently around. There we go. Don't poke it. Just move it. Perfect. Now, I'm hoping that you're seeing what I'm seeing here. And you noticed that this has completely now changed. Let's see if I can, there we go, put on the side. Probably not a good idea because I've got white on. But I think you should see. Nadia, can I borrow your Polymorph?
Sure.
So I can just show the difference. So this is what, here we go. This is what they looked like initially. So the beads were white and they were separate, a little bit like rice. But now they have come together into one, one blob. And the other very noticeable change is they are now transparent. Now they're not all colorless. That's another word we could use. Okay, so they're no longer white. Okay, what we're going to do now, hopefully the water is not too hot now, but I'm going to use my fork to extract it. And I'm going
Lab technicians, younger children might need help with this step.
Yeah, it might be still a little bit warmish. Now, what we're going to do is actually mold it into a bowl. And you might need to help, the scientists may need a bit of help with this, but basically just roll between the two hands, just like this, nice and slowly, and look at that.
Wow.
How did I go with that? Now, so that looks completely different than what it started off. Now, what actually is this? So this is actually another example of a polymer. We have a bit of a theme going on here. So this is another example of a polymer. It's called Polymorph. And this type of polymer, it has nothing to do with absorbing of water. It just has a very interesting property that when you add hot water, which is basically just giving it energy, heating it up, it changes its structure. And as you saw, it becomes quite malleable. In other words, it can be molded into any shape. So initially, the beads were quite hard, and you couldn't mold them into any shape, whereas now, once they're nice and soft, I can mold them into anything I like. Now, Nadia, you've got some warnings to say about that, so please talk about that. And I want you to just keep looking, observing what happens as Nadia is telling us some.
So keep looking at what Magda is rolling there, and hoping that you're making the same thing at home. This is an important safety note for parents, for lab technicians. Don't let people mold this into a shape around fingers or any other body part. It will set in place and will be very hard to remove. So that's why we're forming it into a bouncy ball today, because that is the best shape for it. And okay. I believe we have a question.
There is a question. I like that one. Your polymorph is stuck on your fork. Okay, so what I suggest you do, you probably poked it maybe. I would just put it back into the water, and if you want to add a little bit more hot water, but you can just use your hands just to pull it off. That's fine. Don't be worried about it. It probably is very sticky. That's fine. So just pull it off the fork and then start molding it again. How's that? Is that working? We'll see if we get an answer. Now, while we're waiting for that answer, I want you to just have a look again at your polymorph, and hopefully you're observing something, that it is now slowly changing its color again, and it's no longer totally transparent, Nadia. You can see that it's slowly becoming, there we go, perfect. It's actually going back to white. And also, if you now just touch it, don't poke it, but just touch it gently, you might find that it is hardening. And in fact, what's happening is exactly that. As it cools down, you'll find that it's going to go back to the color and the actual morphology of what we started off with. So it's going to go back to that hard white texture that we had. Now we have an excellent question here. How does the chemical structure change? Well, the actual chemical structure doesn't change because we haven't done any chemistry on this. All we have done is rearrange the atoms so that they're in different positions, if you like. We've given them energy to move them around, but we haven't changed the chemical structure. Now I'm going to put this aside because we need a little bit of time for it to cool down, but we're going to come back to it because I'm going to show you something really cool with this. So another example of a polymer that has very interesting properties. So hopefully everyone's got a nice ball like this.
Magda, we did have one question. Our polymorph did not turn transparent.
Okay, I know what could be the problem. If it hasn't turned transparent, maybe your water wasn't hot enough. So what I would recommend, it's not a problem. I would recommend you heat your water again. Just wait till it's below 100 degrees, so it's not boiling, and then put your polymorph that is not entirely transparent back into the beaker or your glass or your mug, and pour the hot water on top, and it will work, okay? And you can come back and do it later. But now, I think it's time to do another experiment, and this one is completely different. So we're going to stay away from polymers for a little bit. So let's do something different, Nadia. And this is actually one of my favorite. Well, yes, one of many.
Yes, normally Dr. Magda does this experiment, but today I get to have a go. So we're going to go back to your kit, and you're going to take out one of the the clear plastic tumblers. There we go. And you're going to go into the pile of the stack of your other tumblers, and inside you're going to find the plastic bag that has 2 vials of food colouring in it. You have red food dye and green food dye. We're going to use the red food colouring for this experiment. So open your bag, take out, you need to push it out if it's a bit hard to get your fingers inside. We're going to use the green one later, so you can put that to one side. So here's my red food colouring. Remember, food colouring will leave stains on your fingers. They will wash off eventually, but because we've got gloves on today, that probably won't be a problem. These are called Eppendorf tubes, and scientists use these to store or mix very small amounts of chemicals in the lab, or sometimes cells. They have a flip top lid, and an important safety note to lab technicians, these are not toys, so please make sure young children don't handle them. You can push open the lid and it will flip open like that. There we go. Oh, I forgot, we need to put some water in our glass first. I'm going to use some from our beaker left over from our previous experiment. This is not hot water, this is cold water. No need to measure it exactly, but a little bit less than half full. And then we're going to gently tip in some of the red food colouring. You don't need to use all of it. Oh, actually, maybe you can use it all. There we go. Okay, you're finished with the Eppendorf tube now, so you can push the lid back on and you can put that out of the way. We don't really need to stir it today. You can just give it a little swirl, and we're going to keep the spoons in your kit to stir other things later on. Okay, now go back to your kit and get your bottle of canola oil. This is regular canola oil that you would use in cooking. Just take it out of the bag, unscrew the lid, and pour some in until the glass is nearly full. Again, no need to measure it exactly. And if it takes all of your oil, that's fine. But if there's some oil left over, that's also fine. Note to lab technicians, if there is leftover oil, don't use this one for cooking because it's been in a laboratory.
Oh, okay. Nadia, that looks good. Yeah,
so now we've got a nice layer of oil on the top, that's yellow, and we've got our red coloured water underneath.
Yeah, let's do it. Yeah, let's do a little zoom in because
oh, lovely. That's nice work there.
This is so important. You got to pour it carefully. There we go.
So we've got two layers there. I've actually got a little bit that's floating on top.
That's okay.
Yeah, that's okay. We'll give it a little extra layer. Okay, we need one more thing from your kit. In the same glass set of cups where you got your food dye, you will also have a packet with a Barocca tablet inside. While it's still in the bag, try and break it into a couple of pieces. It doesn't matter exactly how many, about 4 is good, but if it breaks into more than that, that's also okay, because we only want a little piece at a time. Now you can open the bag and push out one piece and squeeze it out like that. Okay, we ready? Yep. Casper's going to zoom in for me. Oh, this is thanks, Casper. Nice and close would be good. Oh, yeah. Fantastic. Okay. Is everybody ready with theirs at home? I've got my... Just move it a little bit so it's... Sure. Not, yeah. How about over here?
Are we putting in the oil?
The oil is in the way, yeah. That's right.
Oh, I see.
Yeah,
yes,
sorry.
There we go.
There we go.
How's that? That's a bit better.
How much?
No, what was we putting in the oil?
What,
yeah.
Sorry?
The tablet? What
Okay, so the oil is, you've poured the oil into your cup.
Barocca. Sorry, Barocca tablet. Yeah.
Yep.
Sorry.
On top of the water. Mine has a little slick of the red water that's actually floating on top of the oil as well because it got a little bit stuck. But most people oil, and underneath that a layer of your red coloured water. We also have our piece of Barocca tablet.
Okay, this is the fun part.
Okay, here we go.
Make sure
ready?
you're observing, everybody.
So everybody get your little piece of Barocca, and then when you're ready, drop it in and watch what happens. Ooh. Okay, so Barocca tablets are what we call effervescent, which means when you put them in water, they fizz. The fizzing is lots and lots of tiny little bubbles, and they are pushing their way up through the water, and because they're less dense than water, they're even less dense than oil because they're full of gas. So they're pushing up through the oil as well, and they're floating right up to the top. They're taking a little bit of the red water with them. When they get to the top, they're popping, and then the red water is sinking back down again in nice little beads. And it looks a little bit like a lava lamp. So that's why we call this the lava lamp experiment. You can add another piece of Barocca.
Yeah, let's do it.
Yeah,
Come on,
so
Nadia.
getting another piece out.
That
Here we
looks
go.
really, I have to say, Nadia, that looks really good.
Here goes another piece.
Now, can I put another, a different effervescence tablet? What do you think?
I think so. I think you certainly could.
So
Anything that fizzes will do the same thing.
So that's a bit of experimenting.
Yes, you can try something at home. Aspirin tablets work well as long as you're not allergic to aspirin, but any effervescent tablet will do.
And of course, if you are using any tablets, you have to ask your parent or your guardian for permission, right? You can't just go and grab it. Yep. Well done, Nadia.
Woo.
That's really, I know. You could play with this for a while. Now, I'm assuming everyone understands why the oil floated on the top, but that's a really good talking point and discussion. So maybe you could investigate that. Why is it that the oil, it gets a little bit complicated. It has to do obviously with polarity. So for those of my scientists who are a little bit more advanced in chemistry, it has to do with the fact that the oil is non-polar, whereas water is polar. You know, there's quite a lot of concepts around here. So though it looks like a fun experiment, it actually has a lot of science behind it. Okay, that's well done, Nadia. I like that one. You know what I'm thinking? Should we put it up on here so it continues?
That's a very good idea.
And I'm going to do another fun experiment.
We've got a very good question just before you get to that. Can you touch it? Yes, you can.
Are you going to get
It will feel a little bit oily because you'll be touching cooking oil. But yes, you certainly can touch it. No problem at all.
Well, as long as you've got gloves, because the food colouring will stain you. So
that's true.
Just pay attention to that. Okay, can I do an experiment, Nadia?
Yes.
All right, I want to do one. But before I do, can everyone please have a quick look at their polymorph bowl? What does it look like now? Caspar, can we do a little zoom in? Here we go. Now watch this. Hopefully it will work.
Oh, wow.
Can everyone try that? And I've created a bouncy ball.
Yeah.
And you can see that it is now, it should be totally white now and very, very, very hard. All right. Don't forget, there's your bouncy ball, so you've got that. All right. I'm going to play with some more polymers, okay? All right. Okay, go to your box of goodies, and I'd like you to take out 2 Petri dishes, the ones that have the deep side. Okay, place them on your tablecloth, chemical tablecloth, and then I need you to go into your box and locate nappy sample 1 and nappy sample 2. Okay, I'll give you a little bit of time to do that. And also tweezers. And also,
Good dye. Yes.
now Nadia has already used the red dye, so we're going to go for the green one. Okay, so find, well, you've already would have found this. So just try and, Oh God, this is difficult. Just get the green dye out. We'll also need a plastic cup and some water. Just cold water is fine. So I'm going to transfer probably about 3/4, full cup, doesn't matter. And then I'm going to remember how to open the endorphin, just very gently, just with your fingernail, just push it up and probably transfer about half of this into your water. That'll do. Whoops, I think I did more than half. Oh well. Now, if you want to stir, then have a look in your box of goodies and you will see this very specialized equipment we got for you. Popsicle, used for many things. So if you want to give it a stir, there you go. All right. Okay, are we ready? I think you're ready. Let's do it. Open up nappy sample 1 and using your tweezers, just gently take out the nappy, place it in the middle of the Petri dish and place the packaging in front of it. So we know this is sample 1. And then we're going to do the same for sample 2. Here we go, gently take it out. Now they look exactly the same.
They do look exactly the same.
That's why we have to have the labels, otherwise you're going to forget which is which. They may look the same, but they actually are from different nappies. Now, believe it or not, but nappies contain a polymer. And the polymer, again, is very different than what we've already dealt with in terms of polymorph. This is a different type of a polymer. I'll give you the name for it. It's polyacrylic acid. Now, I'm going to actually show you what it looks like because for some of you, you think, oh, this is a bit complicated, but that's okay, right? Because you'll come to university one day. So I don't know if Casper could zoom in on this because I want to show you what so it's composed of acrylic acid, and then you just link it together, lots and lots and lots of acrylic acid molecules form poly meaning many. So if you ever wondered what's inside a nappy, that's what it is. Now, Nadia, what a nappy is good for? Tell me.
What a nappy's good for? Soaking up things.
We're being a bit funny. Hang on, I've lost who I am now. Yes, they soak up certain fluids. All right, look, we've all had a nappy. Come on, just because you're an adult doesn't mean you've never worn a nappy. We've all worn a nappy, so they're good at soaking up fluids. However, this is serious science because not all nappies have the same absorption properties. So what we're going to do now is, and this is a scientific experiment how you would carry out if you wanted to see the absorbing properties, qualities of the different nappies. So some nappies are more expensive than others, probably because they're better quality. So let's have a look. How are we going to do that? Well, let's think about it. How would you determine the different absorbing properties of two different nappies? Well, you would see how much water each absorbs, right? All right, well, that's what we're going to do. Now, please go again into your box of goodies and locate a pipette, plastic pipette. Everything's white. It's hard to see. Okay, that's what it looks like, plastic pipette. Now, Casper, that's good. Can you zoom a little bit more? Because I want to show everybody how to correctly use a pipette. Seems pretty obvious, but it's a little bit more to it. All right, I'll hold it here. Now this plastic pipette holds approximately 1 mil. Now I'm saying approximately because this is not a super accurate instrument, but that will be okay for us for this experiment. So what you need to do is squeeze the top. There you go, as much as you can. Place it into the solution. Slowly let go to fill up. And then what we're going to do, watch this, we're going to go to nappy sample 1 first. And can we zoom in a little bit? Perfect. So I've now got 1 mil, and I'm going to just slowly, drop by drop, observe what happens. Now I'm hoping you're seeing the same, what I'm seeing. All right, you can be a little bit fast. So we're going to do this again. So I've now put 1 mil. We need to sort of keep an count. So perhaps, could my lab technician do the counting, please?
Yes, that's fine.
I can't do 2 things at once. So that was 1 mil, Nadia.
That was 1 mil. Okay,
so please ask your helpers perhaps to just keep a count on how many mils. That's going to be important. So that's 1. I'm going to keep going. You can be a little bit faster now, but I want you to watch what is happening. Now try and stay.
That's 2.
I'm going to stay on the nappy. So just be careful. Try not to pour the green, green solution.
That's 3.
Now, are you seeing what I'm seeing? Does that look like it's getting bigger?
Yeah.
Well? It seems to be growing.
Oh, man, Dr. Magda, I can see it growing. That was 5.
All right. Can I keep going? Now, we're going to keep going until the very first time I notice that the green liquid seeps out. Okay?
Oh, okay. So we're going to look for when the liquid starts to leak out the bottom.
That's
7.
right. 7. All right.
Is there liquid there?
Oh,
No, it sucked it back up. 8.
Oh, a little bit.
Yeah, a little bit there.
See if I can do one more.
Oh, but it sucked it back up again.
I know. It's 8. What are we up to? 8.
That was 8.
Okay, that's 8 mils.
It's still growing. That's 9.
Can we go for 10?
See if we can get 10.
Oh,
10.
Now, I just want to compare something. Casper, if you could just zoom out a tiny little bit, because look at, look at the size. Now, that actually should make sense to you. When you see a baby and the bottom looks quite big, what does that tell you?
Oh,
It's got a very wet nappy.
That's right. So, okay.
It sounds like we're getting some really big samples.
Gigantic. Ooh, okay, let's keep. So what am I up to? Who's counting? I've lost.
That was 10.
Okay, so that's 11.
11.
We'll be here all night. 12.
12.
Oh, I think this is it.
13. Oh,
Because
I can see some green leaking out the bottom.
I think I would say that would be a stop.
Aha.
Okay, so what's that? 13?
13 milliliters.
Okay, yours might vary a little bit because when I was cutting these up, I obviously did not use a ruler. I did it roughly. So I'm going to talk about that in a minute. But let's quickly now do sample 2.
We had one that started to leak at 6.
Ah, 6. Okay, let's have a look at people. If you want to tell me the volume you've got for nappy sample 1, type it in, and I'm going to start on nappy 2. So please do type in your volume for nappy 1. And we're going to count this in our heads.
So do you think this is going to take more or less or the same?
No idea. Absolutely no idea. So that's 1.
Oh, I can see the numbers coming
2.
in.
What are the numbers?
We've got some 11s, 7s, 8s. 3.
This one looks different.
4.
Oh, hang on. I think.
Ooh.
That's already leaking, that one, Nadia.
Wow.
I reckon maybe just one more. That's it, 6.
6.
So that's half.
Ah, yeah.
And it's not as big. Let's see what others say. Let's have a look at scientists. We've got 11.
Wow.
Now, I'm assuming this is all for sample 1.
Wow, there are some really interesting numbers
Quite a
there, Dr.
variation.
Magda.
And as I said to you guys, this experiment was a little bit hard to do because I was cutting it up roughly. So to do this properly, I would suggest you would measure the size, but also weigh the actual nappy. Now let's have a look at some other numbers. Sorry, I'm just looking at the screen. Oh, they had sample 2 bigger.
Ah,
Okay.
interesting.
Unless I mixed them up. So definitely sample 2 should have been less. But again, as I said, it was difficult because the sizes were varied. But I'm going to give you some statistics here and make sure I've got it right. But in fact, a typical nappy can absorb up to 150 mils of water, which is about half a cup.
Wow.
So there you go. It's, you know, that's a lot.
That's
right?
a lot.
That's a lot of liquid to absorb. So such an interesting compound, the polyacrylic acid, has such fantastic properties. We can use it. You know, I'm sure mothers all over the world are thinking, yes, thank you for coming up with this type of a polymer. Very, very useful. So, yes,
Dr. Magda, we've got an interesting question. Why does it suck it in?
As opposed to suck it out. It sucks it. Yes, excellent question. Can I go back to, I'm going to give a very scientific answer.
Yeah.
Because you guys are pretty good now, I can see. So if you have a look at the actual structure here we go. So, whoops, I've got to start from here. So the acrylic, I'm not very good at camera, am I? Acrylic acid is composed of, it's got a carbon in the middle here, that's a carbon atom, and there's double bonded to an oxygen, and it's single bonded to an OH group. And you see these groups, the OH group and the oxygen here, whoops, carbonyl group, they love water. They will form what's called a hydrogen bond with water. And as soon as they're in vicinity of a water molecule, they'll grab onto that water molecule. So literally what it's doing, which is exactly what the question asked, it's sucking. As soon as it's in the presence of water, it's sucking that water in. So it's just binding with the water molecule. Is that an okay answer, Nadia, do you think?
So. I think
Scientific.
so.
All right, so that's my nappy. So that's another example of a polymer. But now I want to do something fun. This experiment is, I have to say, no matter how old you are. So I'm hoping that perhaps the lab technicians will join in and do this experiment as well, right? Because we're going to have a bit of competition. I'm going to do it as well as Nadia.
Oh, okay.
And we're going to have a competition. We are going to see who makes a better slime.
I'm just going to get some more water because we're going to make 2 batches.
All right, but I'm going to show you guys what you need in the meantime. So I'm going to put this aside. So you're going to need your another cup. Let's get a clean cup. Grab another cup. And I'm going to put this aside. Okay, now, did you want to tell them the rest?
Okay, so we need to use the same green food colouring solution that you just used for your nappy demo. Now, Magda has one she made, but I didn't do the nappy demo, so I need to make one now. Okay, that's what I'm going to do first.
Okay, and while Nadia is doing that, I want you guys to go back to your box and locate this compound here. It's called metamucil. It's in a container like this. There we go. Whoops, whoops. And metamucil. It's a powder, creamy coloured powder. There you go. Right. Are we ready, Nadia? Let's do it.
Yes, we are ready.
Competition time.
So here we go.
Okay, what are we doing? Tell us.
Okay, so First you get your Metamucil, unscrew the lid and tip all of your Metamucil into your empty cup. There you go. And then you can put the lid back on and put that to one side. So now you have a cup with Metamucil. And
sorry, Nadia, can I smell it?
yeah, that's a good idea.
Because as a scientist, I always am interested in looking at the texture, but also I want to see if there's a smell. So I'm just going to gently. Okay, that's a bit of a orangey smell. I guess because it's orange flavored Metamucil. Woohoo! Okay, good. I'm satisfied.
Okay, we're going to go back into your kits now, and we are going to find there are a stack of little tiny cups, but one of them is bigger than the others. So we're not going to use the small one yet. We need the big one. It's a bit squishy, and if you look on the side, it has some little numbers. You can use them to measure with. We're going to, I think we'll measure, we'll fill it up. So take your food dye. You can take out your stirrer if it's still in there because you don't need that anymore. And we're going to pour in enough food dye to just about fill the cup. If you can see the markings on the side, go to 30 millilitres, which is almost full. Now, we need one more thing before we put it all together. In your kits, find the stack of plastic spoons and take one out, or you can undo them all, but you only need one now, the rest can wait for later. Okay, so now you have your spoon, your Metamucil, and your cup full of green water. Now, Magda, how much should we pour in?
Well, so we're gonna start off with 30.
Okay.
And then see what happens.
So, pour in the 30 mils of water.
Yep.
All of it. And then stir it with your spoon. Watch it, but also feel with your hand that's stirring and see what you can feel. See what you can observe. I can smell too.
Well, that's interesting, Nadia, because initially it was very liquidy, but now it's becoming quite gluggy and
mine's got thick.
But now, Nadia, what's the characteristic of a slime? Because we're making it.
It's slimy.
Which means it should. Okay.
Could you call this slimy, Dr. Magda?
No way.
No.
That's not a slime. So what can we do now? What would you suggest?
I think we need to add some more water.
Okay.
So refill your little cup.
Now this is hard because we don't know exactly how much. So this is a bit of a trial and error. So we're just going to add another 30, see what happens.
Okay, here we go. Add it all in.
And then keep stirring.
How's everybody's going? Ooh, it's changing, Dr. Magda.
What's happening?
It's getting...
Now make sure, Nadia, because I can see you've got a little bit of Metamucil right at the bottom there.
Oh.
So really make sure you give it a good stir. Now I'm going to do my slime test. This is a very scientific test. Ready? Yeah. Oh, it's still not slimy enough. It should hang around for a bit longer. I think someone's actually done some measurements on how. Here we go.
Oh, it's going to drip up.
Oh, So maybe just a tiny bit of water. I just need to do a little bit of water. I don't wanna
Okay, so if yours is still a bit too thick,
just,
add a small amount more water.
you need to be,
And like Dr. Magda said, check the bottom of your cup. Don't turn it upside down. Lift it up higher and look underneath and see if you've missed any Metamucil. Oh,
check this out. Did you capture that? Okay, let's see yours, Nadia. It's not easy. It's not
Here we
easy
go.
being green. Oh, that's good. Okay, so I'm hoping everybody is able to do this. Take some photos, guys. If you, my fellow scientists, take some photos of your slime. Here we go. Here we go. That's what we want. See this? Nice and slow, hanging out.
See if I can get
Look
this
at
right
that.
on
That's
the
like
camera.
the perfect slime. Yeah.
Achoo.
Now I wonder who is better at this, the
Ooh.
scientists or the lab technicians?
Yeah, I wonder.
Mm.
So Magda, Dr. Magda,
Yeah.
why is it doing this? Why is it getting all gooey and slimy?
Here we go. Well, oh, sorry, I got excited. So Metamucil has an interesting property that it, again, we have a theme here, it absorbs water and it forms these gluggy, I don't know what you want it forms a slime. What can I say? That's a technical word for it. But the other thing you'll notice, Nadia, is you notice that now it's taking up a lot more space, right?
Mm.
Yeah. So, so it has absorbed the water and it's taking up a lot more space. So if you, yes, if you have that in your stomach, it would expand.
Is that why people eat Metamucil, Dr. Magda?
Perhaps, Nadia, perhaps. I'm not going to go into the science of Metamucil. Can you? Oh, Nadia, can we do this? Come on, everybody. We've got gloves on, right?
Some of them haven't now.
So this is okay. Shall we?
Yes.
You know what that means, though? We're going to have to take these gloves off. Ta-da.
We can wipe them. We've got paper towel. So yes, you can touch this slime. Some slime recipes use a compound called borax, which has boron in it. And there are some health concerns about borax, but this recipe doesn't. So it's quite safe to touch. It only uses a food product. It will swell in the stomach if you eat it before it's already had water added to it. But once it's had water added to it, all it will do is make you regular. So it's quite okay to touch. Now, I'm going to I don't have a spare pair of gloves, so you can use a piece of your paper towel and you can wipe your gloves just to get the slime off.
So look at that. I've actually managed to clean my gloves, so that's really good. Just use your paper towel to wash off, to wipe off the slime. Got a lot of green things happening here. I might just move this aside. All right.
Okay.
Is everyone ready for has everybody cleaned the gloves? I'll give you a,
Yep, mine are clean.
yours are clean, mine are clean. Any questions that I could answer? Will it work on anything besides water?
That was for the nappies.
Oh, was that for the
Magda.
nappies?
Yeah.
Yes.
Good question.
We. Is sorry, is
But
that
maybe don't try that one at home, boys and girls.
yeah, not sure how to answer it.
Well, I suppose water's the best thing to use,
Of
isn't
course,
it? The
yeah.
preferred thing to use, yeah.
Yeah, because as I explained to you, the actual chemical structure is that the actual structure of the acrylic acid, polyacrylic acid, has these has the ability to bind to water molecules that forming the hydrogen bond. So yes, but of course, yeah, we use mostly water, right? It's just different color.
Bit more smelly.
That's right, but we decided to go with green. Okay, I think.
So I think
Yeah,
we've got
sorry.
a couple more questions, have
Oh, we've got more questions? All right. Why is it slimy? Oh, chemical reaction. Oh, people love the slime. So why is it slimy? That's just what the texture is when the Metamucil absorbs the water. And in terms of the chemical reaction, it's an interesting one. I'll have to look that up. I don't think it's an actual chemical reaction as such, because you're not actually forming another compound, you're just absorbing the water again.
Metamucil is made from a natural product called psyllium husk.
That's right.
And it's absorbing the water, which we coloured green, which is why it looks green. It forms what we would, in science, we would call a gel. Gels are interesting because they're not quite solids. They don't do what solids normally do. A solid thing stays the same shape and takes up the same amount of space all the time. But this doesn't, because we can stretch it and it'll flow like a liquid. But it's not quite a liquid either, because it stays partly in the same shape. So gels are somewhere, they're an interesting mixture of properties, and they don't behave the same way as what we call Newtonian liquids.
Yeah.
Or Newtonian fluids, I should say. Newtonian fluids flow in a predictable way, but slime doesn't. So we call things that behave like slime a non-Newtonian fluid. Now I can think of a non-Newtonian fluid that I like to eat, and it's not Metamucil. It's a bit different to this type of slime. This is a thickening fluid, but tomato sauce is a stir thinning fluid. And if you apply a force to it, if you push the bottom of the sauce bottle, it will flow a bit easier.
That's really interesting, Nadia. Nadia is full of amazing facts.
Mostly about food.
But I just quickly, there's a few questions here. Can we eat it? I'm assuming you're talking about the slime. And as Nadia pointed out before, remember that this is obviously a food product, but it will expand in your stomach, and you can eat it under the instructions that are provided on the container. There's another question about bouncy ball. How high can it bounce? That's an excellent question.
Wow.
I haven't tested. Someone's done it. 15
Someone's
centimeters.
measured it. Well done.
So I don't know. I'm a bit too scared because I might lose it. All right. I think we're ready for another experiment. And this one's going to be completely different.
Yes.
And I'm going to need you, Nadia, because we're going to test your ability to smell.
Ooh.
Now, I have a question for you before we get going. Do you know what animal has the best smell?
The best smell?
Is able to smell.
Which animal has the most powerful sense of smell?
Yeah.
I don't know. Maybe a dog?
Anyone else can answer some questions?
Write in which animal you think has the best sense of smell.
Well, poop.
And why are you doing that? Why are you thinking? A shark. Woohoo.
Wow.
And why are you doing that? Can I get you to go into your box and find a little plastic bag that has 4 Eppendorf tubes labelled 1, 2, 3, 4.
We've got lots of dogs and sharks.
Dogs and sharks.
And I like Macy.
Salmon.
Salmon.
Ooh, I love salmon.
Interesting. Bears.
Oh,
snake.
bears.
Ah.
Snake.
I think we might need
That's
to
all
do
right.
some animal research, Dr. Magda.
Well, actually, and again, I'm not a biologist, but from what I know, it is actually a dog that has the best, and they are used in a lot of different, as you know, they're used to sniff out drugs, but also these days they're used in quite interesting area of even in medicine. They're trying to sniff out, for example, people who have cancer. So it's amazing ability. Well, let's see how good we are at smelling and identifying different smells. So hopefully you've got the, have you got the tubes, Nadia? Yep.
Yes, I've got the tubes now.
The other thing you'll need, Nadia, is this in your box where you had the periodic table. You should have had a sheet, a worksheet that says, how good is your sense of smell? Identifying various odors. Now, what I've done here is into these different tubes, I have placed only a few droplets of the following compounds. Now, I haven't told you the name of the compound. I've given you the picture of the compound, of the plant, sorry, where the compound is coming from. I've even given you the chemical name and the structure. So for those of you who have done a bit of more chemistry, you'll be able to maybe identify those. What I need you to do now is, we're going to start with number 1. Open up, like we showed you before, just very gently open up. There we go. And then just bring it to your nose and the smell will come to you.
Notice the way that Dr. Magda and I are smelling. Believe it or not, there's a right way to smell in a laboratory. Sometimes you need to make sure you don't smell something too deeply because you might not know what it is, or it might have a really strong or bad smell. So the way we do it is we hold it near our nose. We don't sniff and take a great big sniff. We just breathe normally and we waft the air above it towards us with our hand like this.
Now, the reason why we can do that, Nadia, is because the molecules are volatile, so they convert from a liquid phase, which is sitting on, we just put a little bit of cotton wool, and they're converting into a gas phase. So we can bring the molecules and they'll come to our nose. All right, have you got enough of that one, number 1?
Yes, yummy.
Okay, so have a look what you think it is and write down the name of it. All right, Nadia's going to do it.
I'm going to write down what I think it is.
Now, you've got to give yourself a bit of space because you don't want to, you've just had the molecules come into your nose from one particular. So let's do number 2. Okay, let's try number 2. What's this one like? Oh, this is a tricky one. Ooh, it's quite intense, isn't it? I remember, I do remember. I wonder how our scientists are going. I wonder if finding it. Oh, they're writing some answers. Write them down on a piece of paper and I'm going to give you the answers. So don't reveal your answers to others.
So Dr. Magda, there wasn't, we didn't put the answers on the little test tubes. They're saying with their labels on them.
No,
because that's what we're trying to guess, the actual smell.
Yes, sorry.
Okay, so there's no labels on the tubes. You've got to guess that.
Exactly.
So
Yes.
the tubes will have a number.
Yep. Sorry if I wasn't clear.
But the answer sheet has, for that number, it has a picture that's a clue, and then the name of the chemical that we can smell, and a picture of the chemical we can smell. But what we want you to do is see if you can work out the name, the common name. That means the name we use every day.
Okay, hopefully that, sorry about that, it wasn't clear enough. All right, I'm ready for number 3.
I only just finished, so I'm going to take a few regular breaths to clear my nose.
Oh, that's quite a strong one too. Ooh. I have to look at some of the, sorry Nadia, can I just read you some of the Number 2 smells like, is that okay? Can I read it out?
Sure.
Number 2 smells like a granny's body wash. Okay.
Oh.
Oh, that's okay. All right, and I'm doing number 4 now. Oh, I don't like number 4. What do you think, Nadia? I'm not. Oh, we both didn't like it. I actually forgot what they were because we had them a while ago. Oh, oh, are you finding this difficult? Because I think it's actually not as easy. Now, remember, guys, I have given you some clues. So look at the pictures. That should help you a little bit. So when you say it smells like a toothpaste, what it probably indicates is that particular toothpaste has that flavoring in it. All right, so underneath for your guesses, I can't reveal because I've got the answers on mine. So where you've got the guesses. And Nadia, how did you go? You've written them all?
Well, let's see. Let's all talk together. So,
drum roll.
So, number 1, the picture has some green leaves that are quite wide. The name of the odor is menthol. And my guess was mint.
Well done.
Hey.
It's peppermint.
Peppermint.
So number 1 is peppermint. How many people got it right? Let's see some answers.
Hey.
Well done, Nadia. That was good.
Okay.
Okay, number 2. Number 2.
So number 2, the picture is the purple flowers. And the chemical name is linalool. It's a terpene, which is a type of chemical. I found this one really hard, and I'm guessing rosemary. Oh, I got that one wrong.
Sorry, Nadia. It's lavender.
Oh, lavender.
Well, there was a clue. There was a purple flower. That's right. What is and oh, like somebody says something smells like.
We think it's lavender. You're right.
Oh, somebody got it right. Okay. What about the third one?
So the third one had some green leaves, long and thin, different to the picture of the peppermint. And its chemical name is eucalyptol, which is a bit of a clue, I reckon.
That was a big clue. I hope you got that one right.
I think that one smells like a gum leaf or eucalyptus.
Yeah.
Correct.
Woo.
You got that one right.
Dennis got it right.
I like that smell.
Eucalyptus. All right. And the last one, 4?
Let's see. So the leaves look very similar. So I couldn't tell just by looking at the picture.
That was a hard one.
And the odor name is a complicated one. It's terpenine 4-ol. And I think it's tea tree oil. Oh, I'm right.
You got it right.
I remember that smell from a medicine I used to take that had tea tree oil in it.
And it is, you know, Nadia, it is quite a distinctive smell. And you know what? So you only got one wrong. That's excellent. But actually, this is not as easy as you think because, and there's an excellent question there, which I'll answer, but our noses.
Oh, that's a very good question.
Our noses are quite complicated. We are able to obviously distinguish between the different odors, but we can overexpose our noses to a particular smell, overwhelm it, which means it is harder when you're trying to smell after smell after smell. Now, these days we have instruments which are able to actually determine the exact chemical composition, and they're called gas chromatogram instruments, and they can determine the exact structure, and then we can relate that. There you go. We can relate this to particular smell. But our noses are not that sophisticated. We're not able to determine the chemical structure. So,
but we can still tell one smell from another.
We can. It does depend on the actual size of the molecule itself and the volatility. The more volatile the compound, the easier it is for us to obviously smell it. So we have sensors in our noses that will determine what smell it is. But if you have a mixture, the problem is if I mixed all of this together, there is no way, well, if one was overpowering, but it'd be extremely difficult for you to actually identify all the different smells. So that's why we did them separately. So hopefully you've done well. And number 4.
Now, what was number 3?
Oh, number 3
was eucalyptus gum leaf.
And there's a good question here. Oh no, we answered that about our nose, because you were just talking about the complicated sort of structure of our noses.
Yes, our noses tell different odours apart by their chemical shape. Our noses have special receptor cells in them that have special projections, or like tiny, tiny little hairs on the outside that match certain shapes. And when we inhale air that has a certain smell in it, those chemical molecules that have the same shape that matches the receptors on our olfactory cells, which is the word for things that are in our nose, when they latch onto each other, our nervous system detects that smell and our brain interprets it as a smell. So it all works by chemistry and shape. So, Magda, Dr. Magda, what should we do next?
Thanks, Nadia, for the explanation. I think we are, what do you think of your I think we're ready for your cabbage. That's going to be quite a big experiment. So we left it till sort of second last because we need it for the cabbage to release its colouring. So we're going to use that as a, what's called a pH meter. So while you're getting that ready, I'm just going to tell everyone to, or do you want to just show them how to do that? Can I talk about pH?
No, talk about it, it's fine.
Okay, guys, so in your box, you should find, we have something that looks like this. And that will show you the different colors that you get using what's called a pH strip paper. Now, those pH strip papers are used in chemistry to determine when something is acidic or alkaline. Now, example of an acidic, have I got this upside down? No. Example of a, whoops, example of an acidic compound would be one that has a pH, which is a measure of its acidity, pH between 1 to 7, or before 7. Where something is alkaline, it will be between over 7 up to 14. Now, these are quite expensive strips, but these are very, very useful because they'll tell you the exact pH of the solution. However, we can actually make our own pH indicator using a very simple substance. And for that, you'll use this particular strip, this particular color indicator, and you'll be able to determine what pH that you have. So I'm going to let Nadia explain how the cabbage, how to prepare your indicator right now. And then we're going to test some solutions. Excellent.
Okay, so we've been patiently waiting for our cabbage solution where we soaked our cabbage in hot water to cool down. It should be cool enough to touch now. It's okay if it's still warm as long as it's not too hot to touch. We're going to need quite a lot of space, so you may need to push away the experiments that we've already finished with. Just make sure you don't tip anything over. You can keep your periodic table nearby if you like, and as Magda said, you'll want to take out your little red cabbage indicator colour chart. We want to keep them dry, so put them on the edge of your bench roll, and we'll try not to drip water on them. Okay, we're going to use most of the rest of the stuff in our kit now, one piece at a time. So we won't take everything out at once, but we'll take most things out. So let's see. Take out any of your remaining cups and all the things that are in them, bring them along too. And you can get out the rest of your spoons, the rest of your pipettes. You've probably got 4 left now, but if you haven't got that many, that's okay. And the rest of your pop sticks or stirrers. You can undo those. And your 6 little stiff plastic cups that don't have any measurements on the side, it might have one at the top. And your 6 little miniature test tubes. These are made of plastic, not glass, so don't worry, they won't break if you tap them or drop them. You can undo them. Okay, so we've got a little miniature laboratory here and it's going to take us a few minutes to set it all up and then we'll be able to use our pH indicator. Take your modelling clay, so you have a small packet with some white modelling clay inside. Open up that packet and squeeze out the clay. You might need to squish it out from the bottom like toothpaste from a toothpaste tube. Ah, a bit awkward. There we go.
It's not that easy, is it?
And you're going to squish it and squash it out into a sausage shape. Don't worry if it breaks off a little bit, you can just join it back together like glue tack. You want it to be about this long. No need to be exact. And then put that down on your bench roll. Just going to put it somewhere where you can see it. There we go. And now you're going to use that like a test tube rack. So pick up one test tube and gently squash it into the modelling clay at one end so it stands upright. And then we're going to put all the other ones in next to it, all the way along.
Oh, Nadia, that's so cool.
It is a good, quick way to hold
right.
test tubes
I have to say,
up.
Nadia came up with that idea because we couldn't find tiny little test tube holders. So
I've seen Ruben Meerman, the surfing scientist, do this with straws.
ah,
There we go. Mine aren't very evenly spread out, but that's okay. It'll hold them upright. We're also going to use, all our little cups. So you can open up your cups and spread them out.
Well, I'm ready to go.
Okay, we've got all our stuff together. Right, now, we also asked you to get a couple of things ready to use. If you haven't got them yet, now's a good time to get them, lab technicians. A little bit of white vinegar, just regular vinegar. You don't need anywhere near this amount, just a couple of tablespoons will do. Oops, let me put that over there. And if you like, an optional extra is some colourless soft drink like lemonade or soda water. Again, you only need a small amount and it's an optional extra, you don't have to use it. I've got a couple of extra bits and pieces here today that I'll use if we have time as well. Okay, we've also got lots and lots of little vials and things to test here. Let me get rid of that one because we don't need that. Okay, now I'm going to ask you to look through your vials and get the one that says bicarb soda. So bicarb soda, on the label underneath it, I've written sodium bicarbonate and a little formula. That's the chemical formula for the chemical in bicarb soda. Its proper name is sodium bicarbonate or sodium hydrogen carbonate. And it's the same white powder that you get in the blue and white packets or other packets. Okay, I'm going to get you to take the lid off and then pour some into one of your little cups. Don't try and squeeze it into the test tubes because they're too small. Yep.
So how much, Nadia?
Oh, about half of it.
Okay. Yeah, because we want to leave some behind because you can do some more experiments later. So don't use it all up, right? Because I might want to do some more later.
Remember to put the lid back on so it doesn't spill, and put it next to that container so you know which one which is which.
Good idea.
All right, let's do some more. Let's fill them all up now. I think that's a good idea. So the next one I'm going to get is, oh, not that one, is laundry powder. Now, a bit of safety, laundry powder can irritate some people's skin. That should be fine because we're wearing gloves. It's also not good for your eyes, but we have safety glasses on, so that's fine too. Same thing, open the lid, pour a little bit into one of your other cups. Ooh, nearly all of mine fell in, that's okay.
It's got a strong smell, that one.
It has. And remember, put that next to it so we know which one it is.
Okay, what's next?
Okay, next one, I'm going to get baking powder. Now that sounds very similar to bicarb soda, but it's actually not quite the same. It does have one of the ingredients of bicarb soda, but it has some other stuff in it too. Same thing, open up the lid, pour some in, about half if you can do it, but don't worry if a bit more falls in, that's okay. And put it next to it so we know which one's which. And now we've got a couple more. Here's one, citric acid. Now these are in little tiny vials. These ones, the lids pull off instead of screwing off. Just do that gently so it doesn't fly everywhere.
And again, don't use up all of it, right?
No. You can just put in some.
Yep.
If you're worried it's all going to fall out, you can lean and tap with your finger. Tap, tap, tap.
Oh, good idea.
To help it come out more gently. So far, they all look white and they all look much the same. You can probably see a little bit of difference between them, but not much. Okay, one last one, cream of tartar. Again, I've put the chemical name on there. I haven't put the formula on this one. Same thing, tap, tap, tap. Oh, this one looks a little bit different. It's a bit more like flour. All right, and we've got one last one. I'm going to get you to put the vinegar in that. So if you get your vinegar, feel free to pour some into a smaller container if you want first. And then we're going to pour a little bit in. Don't fill it up, only about half full. There we go, something like that.
Can I have some, Nadia?
Sure.
Thank you.
Okay, goodness me, we've got a lot of equipment here, haven't we? Now, I haven't got, the vinegar bottle is too big to put next to that one, but it's the only liquid we've used so far, so I think I'll know which one that is. I'm going to put the lid back on.
Yes, thanks.
Yeah, there we go. All right, we're finally ready. Okay, we've got a few others. We're going to test them separately in a minute. All right, so now let's see. The easiest way is to get one more cup if you have a spare cup. And dip it into your bowl and push down so that you can scoop out some of the liquid inside. There are other ways to get it out. If you want to, especially if you want to do this again another day and you have a lot of extra space, you could get a second mixing bowl and pour it through a colander or a sieve to sieve out the cabbage. And then you've got a whole container full of liquid, but this is just as easy this way. So I've got some purple liquid here. Now this is purple, just like my hair.
Oh, is that why you have purple hair?
So let's have a look at our colour chart. Compare the colour of your cabbage to your colour chart and see if you can figure out which number is on the square of the colour that it matches the best. It might not be perfect, but it'll probably be closer to one of them than to any of the others. So mine, I think, is closest to number 6. So this is slightly acidic. That happens sometimes depending on which water you use. I used our purified water in the laboratory, which is a little tiny bit acidic. If you use tap water, yours might be a bit more of a blue purple and yours might be more like 7. All right, here we go. So
This is the fun
now
part. Ooh.
get another one of your pipettes. You should have a few pipettes that you haven't used yet. You want to use the clean ones to make sure they don't have anything else inside that'll interfere and give you the wrong colour. So remember how Dr. Magda showed you how to use a pipette. You hold it by the bulb at the top, you squeeze it to push the air out, then you put it down into the liquid so the bottom bit's underwater, and then you let go gently so that it sucks up inside. We're not measuring this time, so you can let it go completely if you like, and it'll suck up more than before. That's okay. All right. So now we're going to get one of our containers, and maybe Casper, if you could zoom in a little bit. And we're going to squirt this into one of our containers and see which colour it goes. I'm going to pick bicarb soda, this one. Are we ready? Yep. Here we go. Everybody get ready to squirt it in.
I'm doing it.
Squirt the whole lot in. Wow.
Oh, what did you get, Nadia? I got
blue.
Yeah.
Now you can put in another pipette full if you like. So you do the same thing. Squeeze the air out, push it underwater, let it go, and then you can squeeze it all out again.
Awesome.
Whoops. There we go. So this has turned blue. Now you can get your colour chart again and see which colour it looks the most like. Now I think mine looks about number 9, I'd say.
Yeah.
Now remember what Dr. Magda said before about pH? Numbers that are more than 7 are alkaline. In other words, sometimes people use is basic. So bicarb soda is alkaline. Ooh, let's try another one.
I know. Are we doing laundry powder?
Yes,
Okay.
let's do laundry powder. So squirt, I'm going to suck up another one. Oh, what colour did yours go? Ooh,
I got completely different
here we
colour.
go. Oh, wow, look
There's
at
lots of
that.
happening.
I'm going to do some more so you can see. Ooh, and apart from the colour, can you see something else it's doing?
Yeah, it's a lot of bubbling there.
Wow, yeah, mine's
This is
fizzing a little
fizzing
bit.
away.
Ooh. So mine is a deep dark green. That's a really pretty colour, I think. So I get my colour chart back again. Now let's see. I think that's about 11
yeah, I
for
reckon.
mine.
Yep.
Yeah.
11 and a half maybe, even.
Are you getting the same at home? Let's try some more. So laundry powder is quite alkaline. That's part of how it works to remove the dirt from your clothes. Okay.
Wow, I've just raced ahead.
Which one have you done?
I'm just doing baking powder.
Baking powder. Now this is interesting, baking powder. Ooh.
It's gone wild.
Whoa.
Got to be careful with that one.
So my baking powder hasn't really changed colour at all, but it's doing something else. It's fizzing. It's fizzing a lot. Now, that's because baking powder has a combination of ingredients, and when they're dry, they don't do anything. But when they get wet and dissolve in water, some of them react with each other and they make a gas. That gas is carbon dioxide, and those are the bubbles you can see. And that's how baking powder works. To help bread rise or to help other things puff up in the oven. They actually puff up from the bubbles of carbon dioxide that are created while it's cooking. All right, let's pick another one. I'm going to pick citric acid now. That's this one here. Here we go. Let's try this colour.
Oh, what are we doing? Citric acid.
Oh, look at that.
Oh, I love, that's my favourite colour.
Yeah, that's beautiful.
Oh, Nada, can you do your hair like that next time?
Okay, challenge accepted. Okay, so let's have a look at citric acid. Wow, I think that's about pH about 2, I think.
Yeah.
Oops, hang on, there we go.
Look at my colours. Casper, look at my colours.
So citric acid is quite acidic, and it's the acid that's in lemons.
Oh,
And it's also used to clean dishwashers and things like that. Oh, look at yours, all nice and aligned. Wow, very nice.
That's right. I had time to. Can I do that? Okay, I'm doing the next one.
Okay, let's do the next one. Cream of tartar is my next one. Here we go.
Right.
Ooh.
That's
now, I don't normally do cream of tartar.
Ah, that is, it's pinky.
It is. It's pink, but it's not as pink as the citric acid, I don't think. It's closer to purple than the citric acid.
Let me have a look. I'll just show everyone.
Yeah, there we go.
What do you think? Is it more a 2 or 3?
I think mine's a 3 or maybe even a 4. So it's acidic, but it's less acidic than the citric acid. All right, so we've got one more.
Vinegar.
Let's do another one. Okay, so now we've got vinegar. Ooh.
Now that one is about 4-ish.
There we go. Yeah, I think so. Mine's about 4. Yeah, something like that.
Well, that makes sense because we do put vinegar on our chips.
That's right.
So we can't have it too acidic, right?
So vinegar has acetic acid or ethanoic acid in it. And yes, that's a weak acid. So it's not really, really acidic. But it's fairly acidic. All right, so now we've used some of the little vials, but we still haven't used our test tubes yet. So let's have some fun with our test tubes.
Okay, I'm ready.
Okay.
What do you want me to do?
So now what I'm going to get you to do is get a new pipette, another empty pipette, so it's nice and clean.
Yep.
And then squeeze the air out, and we're going to put it into the solution.
Right.
And then suck up some of the vinegar solution.
Yep.
And then we're going to put it into one of our test tubes.
Yep.
And squirt it in. So it's probably about half full or maybe even 3/4 full. If it's really close to full, put the end back in and suck a little bit back out. And you can put it back where it came from. So it's about half full.
Okay.
Okay. Now I'm going to go back to my bicarb soda. That one doesn't have very much liquid in it. So I'm actually going to put in some more indicator. I'm going to put in another, I think I might put in 2 squirts to make sure I've got plenty in there. There we go. Now I'm going to take another clean pipette, same thing, squeeze the air out, put it in, just put it in a little bit so you don't stab right down into the solid that's still at the bottom. You only want the liquid, and suck up a bit of the liquid, doesn't need to be too much. And then bring it over to the same test tube, and on the count of 3, we're going to squirt it in. Before we do that though, I want you to predict what you think is going to happen. So we're adding something that was pink, that's an acid, and we're combining it with something that's blue, that's a base.
Should we do it like drop by drop, Nadia?
Oh, sounds good. Let's do one drop at a time. Ready? Here we go. Go.
1, 2.
Oh, not much happened there. Oh,
fizzing away.
Let's see.
Like crazy.
I'm adding some more.
Hang on,
oh, I can see some fizzing now.
Be careful, but that's okay. We've got the
we've got the bench roll. That's all right. I'm squirting the whole lot in.
All right, you're brave.
So mine's fizzing a little bit, and it's changed colour. Oh, yours is fizzing more than mine. That's not fair.
A little bit of a mash. You know why we did this experiment last, right?
Yes. So, lab technicians, this is a great experiment you can do many times at home.
Purple, Nadia. Look.
Oh, it's turned purple. So mine's turned pink.
It started off pink, then I added the blue, and now I've got purple.
Mine's still pink, so I'm going to add a bit more and see what's happening here.
So I think what Nadia is doing, which she might be able to catch it, she's trying to probably try and catch the neutral.
Yeah, I'll see if I can. So we're adding something that's acidic and something that's basic together, and they're neutralizing each other, which means they're sort of counteracting each other, and they're producing a gas at the same time.
Actually,
guess which gas it might be?
Do you think I've got 7 just about?
Yeah, yours is pretty close. Yeah, mine's still acidic. I ran out of space to neutralize mine. So you can play with lots of them now. I'm going to get, let's see, I've still got 1 pipette left, so I'm going to try laundry powder.
So Nadia, so we can basically, what you're saying is we can mix any of these, right?
That's right. We can mix some. So suck some up and half fill one of your test tubes. And then add something else and see what happens. So I'm going to add vinegar because I've got the most vinegar. So I'm going to add vinegar to my laundry powder.
Okay.
Whoa. Ooh, I've got layers. Does anyone else get layers in there?
Hang on, I want to do that too, laundry powder.
So my laundry powder is green at the bottom and pink at the top.
Woohoo! I think I've overdone it again.
I'm a bit jealous. Dr. Magda's are fizzing a lot more than mine.
Sorry.
But
I'm making a real mess.
I'm going to move. Oh, I'm going to move one over to show you. Yeah, but mine has layers in it.
Hang on.
Ooh, where did it go?
it?
Oh, there we go. Mine's got nice layers.
Has anyone else got layers? I want the layers too. Oh, okay.
So the layers happen when the different components have it.
Here we go.
Oh, yours is making lots of gas again.
Right. Well, you can have hours of fun with this.
Sure can.
Absolute hours. And you are right. We actually had a special visitor joining us today, and that's Mr. Tim Harrison from Bristol University in UK.
Yay.
He's one of our outreach colleagues, and he comes to Perth every year, except he won't be coming this year, which is a shame, but he has joined us live listening. And he's just mentioned, Nadia, that apart from your cabbage, we can also use, instead of using red cabbage, you could use brown onion skins, frozen fruits of the forest, or frozen blackberries.
Yes. Those are a little bit harder to get in Australia than they are in England, but you can sometimes get them here. And Tim's right. That's because the pigment that we're using, that we extracted from the cabbage using the hot water, is from a family of chemicals called anthocyanins. That word is on your colour chart, and those pigments are in lots and lots of plants. Some of them have only a little bit, but some have a lot, and the ones that Tim suggested, as well as red cabbage, do have a lot in them. So you can experiment at home and try extracting in the same way using other things, other foods that are deep, dark purple colour. We do have a couple of tubes left. I reckon we can do a couple more.
Okay.
So I've got 2 tubes that have got liquids inside. Now, they're very thick and gloopy. So I thought instead of trying to tip them into the little cups, which will take ages, we can pipette into? Yes, into it. So if like mine, your liquid has got, your cabbage has got a bit low, top it up from your container. It's okay if a few bits of cabbage go in, that's all right. And I'm going to try shampoo first. So I've got some shampoo here. Take the lid off.
Nadia, can we shake it?
Yes, you can shake it, but gently.
Okay.
Just in case it does something. Ooh, I love the smell of this shampoo. All right, so here we go. I'm going to add in, and I have actually never done this with this brand of shampoo before, so I'm intrigued as to what the result will be. And you can see it doesn't mix very well, so I'm going to shake it a bit and see what, okay. So mine has turned pink.
Yeah.
Yep. So I'd say mine is probably about pH 4 or 5. So it's acidic, but not as acidic as the acids we tried. Okay, one last one I'm going to try.
Antacid.
Yes, antacid.
Should we predict?
So, yes, make a prediction. Have a look at its name, antacid.
Ant means...
What does that remind you of? Let's find out. Okay. Make a prediction as to what you think the colour is going to be. And we'll squirt it in and see. Now this one you will need to shake a bit because it doesn't mix very well. Ooh!
I got...
Wow, look at that. So mine's gone a
10-ish?
bluey green colour.
9, 10? What do you think? 10? Almost 10.
Yeah, I'd say yes. I'd say that's probably about pH 10. Now, that might have surprised you because its name has acid in its name. But if you look at the part at the start of the word, antacid, you can think of it as short for anti-acid. So it's like the opposite of an acid. And antacids are medicines that you can swallow if you're suffering from too much acid in your stomach. And these react with the acid in your stomach and stop indigestion, which is when you get a bit of acid coming up into your esophagus, which is uncomfortable. I think that's one of my favourite colours from today.
So Nadia, that really makes sense because if it's antacid, so it's trying to counteract the acidity, so it's got to be alkaline or basic.
Yeah,
so that's good. We've tested it because it actually is the correct,
just to make sure that it works. So I just wanted to say one last thing about this. This is a lot of fun, and you can have hours and hours of fun with this. You can use lots of different vessels. There are lots of different things you can try at home. You can try fresh foods like lemons. You can try other beauty products like hair conditioner, or you can compare different brands of the same kind of product, like different types of soap. You can use soft drinks. That's very interesting. I recommend trying that. And you can use, you can test fresh lemon juice versus lemon juice that you bought from the supermarket and all sorts of things like that. If you run out of test tubes or little shot glasses, another good idea is to use ice cube trays, white ones or colourless ones, and you can use them to have a whole array, which means a large number of tests all at once. You can even test things like raw egg white, which might surprise you, and lots of other foods. I suggest you pick ones that are colourless or white, just so that you can tell that the colour you're seeing really is because of the anthocyanin and not some other colour that's mixing in with it. And just one last thing, the two pH sticks that we've given you, they work in the alkaline range. They don't work with acids. So if you want to try them, you certainly can. You can dip them into a solution, any solution you like, until all three little squares get wet, and then wait for 30 seconds usually it says. Oh, these are 1 to 10 minutes. And then wait until the colour stops changing, and then you can compare it to the chart. You might have seen other, sorry, I just remembered one last thing. You might have used pH test kits at home. If you have fish tanks or a swimming pool, you might have used pH test kits with indicators in them to check the pH of the water. I do that all the time. I have a fish tank, several fish tanks at home, and I actually brought my kit with me, but I don't know where I've got it right now, so I won't show you. But they all use indicators, which are chemicals that change their shape in acids and bases. And when they change their shape, it changes their colour. And that's how we can tell that it's an acid or a base.
Nadia, that's fantastic. I love the colours we've got here. Now we are almost out of time. So I just want to quickly tell you guys there is one more thing, two more things in your box. And this one here, you'll see these little white bowls. What you can do is use this to create your own molecules. I'll give you some examples. You can create a water molecule. So you may want to paint one of the bowls white, red color, and that will be your oxygen, and the two white would be your hydrogens. Or you can make your own CO2 molecule, carbon dioxide molecule. So that's what you can use this for. Just be careful, they have little sharp ends. So please do this with the supervision of your lab technician. And finally, for the finale, I want you to try and dig out in your, oh, where is mine? Ah, here we go. We have a glow stick. So we're going to get Casper to turn the lights off and see. So if you have your glow stick with you, maybe ask your lab technician to turn the lights off in your room where you're sitting right now. And we're going to do this together. All right, nearly there, nearly there. Right, ready?
Oh,
Okay, so bend your glow stick, and you can bend it in lots of places all the way along. You'll hear it crackle and you might feel it crackle. Once you've done that, hold it at one end and shake it really hard.
Is it glowing?
Don't know, they're a little bit faint.
not as bright as we would expect them, probably, and it's not as dark here, although we'll have the lights back on. So hopefully yours is glowing a bit brighter. Really interesting chemical reactions with, we call that chemiluminescence, by the way. A very interesting reaction. It's similar to in the underwater world, we have some species that glow in the dark, and they use bioluminescence, whereas this is because it's chemistry. You know what? We've ran out of time. It is nearly 8 o'clock. So we've had a lot of fun doing these experiments. I hope you've had fun as well. And please continue experimenting. We've left you with some ideas what you can do. And you're welcome to email Michelle and ask us some more questions. Other than that, I want to thank you so much for participating. Thank you, Nadia.
Thank you, Dr. Magda.
And thank you, Caspar, for being our cameraman. And you can see he was very good at switching from one camera to the other. And of course, Michelle. Thank you, Michelle, for answering and coordinating this. We're going to see you at some stage. Come and visit us one day when you come and study at university. And have a fantastic new National Science Week.